Hello students, welcome back. Myself Pathak. Today we are going to learn some tricks on the coordination compounds. How to solve the coordination compounds based on VDT. Now there are some tips to be followed. Find the oxidation number of the central metal ions. Second, identify the given ligands. Now given ligands are of two types, weak ligand and strong ligands. The weak ligand can be F- and Cl-, whereas strong ligands is ammonia NH3+ and Cl-. So keep in mind that these both are favorable on the weak and strong ligands. Now what about in the weak ligands? When you find this F and Cl, so weak ligands, what happens over here? The electrons do not pair. Whereas in the strong ligands, electrons are paired. That means through this we can identify either the given compound is paramagnetic or diamagnetic in nature. Now here you can see that number of unpaired electrons and Bm is a Bohr magneton. Now what is it all about? How to remember these Bohr magnetons? You can see the number of unpaired electrons is given 0, 1, 2, 3, 4, 5. Now Bohr magneton has a formula of Bm is equals to under root of n plus 2. Now what is n? N is known as number of unpaired electrons. So you will place the value. If it's 0, then you'll get the answer as a 0. Now let us go back to the tricks. Not to do always the same formula. So let's see how this trick has to be followed. Right, as it is over here, after 0, 1, 2, 3, 4 and 5. Place a decimal value. Now as for example, if I place here 1, so 1, what do I get over here? 1 plus 2, I get answer as a root 3. As we all know in the mathematical concept, the root 3 has a value of 1.73. So here I would place 73. Now focus here. Now make the differential decimal value of 10 place value. So this would be answer as an 83. After this, place the 4, make it plus 4, 83 plus 4, you get 87. Then after 87, place 3 plus, do the 3 plus of decimal, you get 90. And afterwards, do the 90 plus 2, you get 92. So this is how you can get through the brains. So difference between 73 is a 10, 83 to 87 is the plus 4 difference, 87 to 90 is a plus 3 and 90 to 92 is a plus 2. So this is how you can find the number of electrons pair and the Bohr magneton. After solving this equation or after solving these tricks, you can find the structure of the compound, hybridization and the Bohr magneton. So students, let's try to find the coordination compounds. Now students, let us solve about the NiCN4 2-. So what was the first protocol? Find out the oxidation number of the central line. So need to find about the Ni, how much is the oxidation number. So we'll replace Ni as an X plus we have 4Cn N equals to minus 2. So X plus 4, Cn has a charge of minus 1 equals to minus 2. So X minus 4 equals to minus 2. So X equals to minus 2 plus 4. We get as in plus 2 oxidation number. So Ni has the charge of plus 2 oxidation number. Now moving back towards its electronic configuration, as we know that the Ni has the atomic number of 28. Therefore, here we write argon completed 3d8 and 4s2. Is that clear? Now we'll arrange here for the Ni. How to get back to the complex compound? So Ni, here we'll place Ar. So first of You can see 3D, so I'll make the block of D block 1 2 3 4. Here this is 3D, this is 4s, and after 4s we get 4p. So P has the 3 blocks. Now arrange this electronic configuration in the d orbital. 1 2 3 4 5 6 7 8 and 4s2 up and down. Clear? Now moving back to this, what is the oxidation number of Ni? Here Ni is 2 plus, so we'll remove the 2 electrons from this 4s orbital. So 1 2 3 4, same pattern. Clear? So as I told that to remove the 2 electrons from the Ni, so from this it will be a vacant, so remaining would be as it is 1 2 3 4 5 6 7 8. Clear? Now as we are aware about this, how to release the electrons, now we'll take the whole compound over here, NiCN4 2 minus. Is that clear? So making the blocks, as we know that the Cn is a strong ligand. So when it is strong ligand, that means what happens? Electrons are paired. So this unpaired electrons will pair with this electron, so you get as a compound 1 2 3 4 5 6 7 8. Now what about this Cn? As we know that Cn, how many moles do we have? 4. So multiply with the 2 part, you get how many? 8 electrons. Now this Cn will transfer these 8 electrons towards the Ni metals. So we get an answer. Keep it as a XX 1 2 3 4 5 6 7 8. Now when we are transferring the Cn towards the Ni, through that we can find the hybridization. D, it's in the D block, so this is 3D, this is 4s and this is 4p. 3D, 4s and 4p. So you can see the one block, that means you will keep as a D, S in the other block, and 2 blocks are filled in the P, right? P2. Is that clear? So this is how we can solve the complex compounds, and as I told you that here we can find the structure. Now what is the structure of this compound? As we are aware about it, it would be the square planar. Hybridization we already find it. Hybridization is DsP2, and Bohr magnetum, that's called Bn. As you can see, there is no unpaired electron, so that means it is 0. So you will get the answer as a 0. Clear? And finally you need to draw the structure. Ni is a central metal atom, so here would be Cn, 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 Cn and Cn. Make sure that you are keeping the arrow towards the nickel atoms. That means the Cn has then donated its electrons towards the Ni and will replace as a 2 minus. So this is how you can find the coordination compounds. Now let's move towards the next one. Now children, let us solve about the FeF6 3 minus. Now you can see here, according to the rules, find the oxidation number of the central metal ion. So here, let's keep it as in central metal is Fe. So X plus 6F equals to minus 3. So x plus 6 minus 1 equals to minus 3. X minus 6 equals to minus 3. So x equals to minus 3 plus 6, x equals to plus 3. So Fe has the oxidation of plus 3. So atomic number is Z equals to 26. That means argon electronic configuration, argon completed 3d6. So it's 28, 3d6, 4s, 2. Clear? Now let us solve the coordination compounds. Now first of all we should know about the Fe. So Fe is equals to argon completed. So let us place the value here for the blocks part. D one, two, three, 4. Now replace the electrons here. 6 electrons in 3D. You can see 1, 2, 3, 4, 5, 6, and 2 electrons in the 4s. So this is 3D, this is 4s, and this is 4p. As we know that Fe has a plus 3, so keep it as an Fe3 plus. 1, 2, 3, 4. So we need to release 3 electrons. So 2 electrons from here and 1 electron from this part. So it will be remaining 1, 2, 3, 4 and 5. Now take this whole FeF6 compound 3 minus. F is a weak ligand, so electron does not pair. So whatever the remaining here in the 3D orbital will remain as it is, and the Fe will give its electron towards the central metal atom. So 6 multiply with the 2, so that is 12. Now coming back over here, when this is over 4p, now 4p will jump towards the 4D orbitals. So 12 electrons I will need to substitute over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now here you can see that I have just given electrons towards the Fe. So this is S. P is completely filled. This is 4p, 4d and 4s. So P3 and D2. So this is what we get the hybridization. Now structure. How to get what is the structure? Then hybridization and 4 magneton. As we know that it's a 5 anti-electrons. So I just told you earlier that the 5, that means 5.92. So here you write 5.92 as a Bm. Hybridization is sp3d2 and the structure is octahedral. And finally we need to draw Fe as a central atom. Here F, and you can give it a number of electron as an arrow towards the Fe atoms. So this is the structure of FeF6. I hope you like the videos. I hope you get the whole idea, and if you like the videos, please like and subscribe. Thank you and have a great day.